If you use Python in your research as an undergraduate or graduate student, you're probably working alone and don't have someone to review the code that you write. I'd bet that you've learned the basics of Python, just enough to be dangerous, and are now off to the races using it to turn raw data into results. In this video, we're going to go over 5 mistakes you're probably making in your Python code and talk about how to fix them. Hey friends, welcome back to the channel. If you're new here, my name is Ben. I recently earned my PhD in engineering, and I help scientists and engineers write better code so they can spend less time debugging and more time doing what they love. Mistake number 1. Concatenating strings and variables with addition syntax. Depending on when and where you learned Python, you may have seen examples of how to incorporate variables into your strings using either additive notation or substitution notation. Stop doing this. The preferred way to write composite strings is to use f-string notation, where variables are wrapped in curly braces directly in place in the string declaration. Oh, and if your variables are printing out to 10 decimal places but you don't need them to, don't waste time rounding the output. Simply use string formatting to specify how many decimals you want, or if you prefer, format it as a percentage. Mistake number 2. Manually correcting backslashes and paths. If you work on a Windows system, the most expedient way to grab a path to a file is to copy it from the Windows Explorer and paste it directly into your code. However, if you try to use this string in Python, you'll immediately get hit with an escape character error. Instead of manually replacing each backslash with a forward slash or double escaping each one, use raw string notation instead by tacking on an R at the front of your string. Problem solved. Better yet, use pathlib to manage your path variables instead of dealing with them as strings. Mistake number 3. Manually opening and closing files. Searches for how to open a file in Python will probably give you template code delineating the step-by-step method of opening a file, reading or writing to it, and then closing it. However, if anything goes wrong during this process and your code doesn't finish executing the whole workflow, you'll lock the file in an open state and run the risk of corrupting it altogether. The best practice for working with any kind of disk operation is to use a context manager with the with keyword. This will ensure that if an error occurs, Python will automatically safely close your file. Still, it's better to do your data processing outside of the context manager and only open the file again to write to it once your program is finished running its logic. Mistake number 4. Using range and len to iterate over a list. If you learned programming in a different language before learning Python, you're probably most susceptible to this mistake. It makes sense that if we want to iterate over a list, we should create a range from that list that we'd like to loop through, and then use the index to access elements of that list during the loop. The Pythonic and more readable way to do this is to simply iterate over the list directly, as Python will automatically pull each element out during the loop. If for whatever reason you still need the index value, use enumerate to count the iterations. If you are using the index value to synchronize looping through 2 lists in parallel, Python has the built-in zip method to do exactly that. And if you still need the index, you can chain enumerate and zip together. Mistake number 5. Timing with the time.time method. If you're trying to benchmark your data analysis pipeline for optimization purposes or to report on how long it takes for different stages of your workflow to process, it can be tempting to use the .time method from the time library. It makes intuitive sense. Get the start time, do your process, get the end time, and take the difference to measure how long it took. The trouble is, the time.time method is making calls to the system time on your computer, which is going to add latency that will affect your measurement. It's effectively like starting and stopping a stopwatch in another room down the hall to time how long it takes for you to do some task. Instead, use the perfcounter method, which is meant specifically for recording relative time within your program and will give you the most accurate measurement for how long your operation actually took. That said, if you're using this to clock the time of a 30-minute long process, which method you use is kind of irrelevant. Well, there you have it. 5 mistakes you might be making in your Python code and how to fix them. If you'd like to see more videos like this, please leave a like and maybe even consider subscribing. Peace.